Okay, so in example 6, we are looking again for the limit and we're using tables, and the problem has two parts. The first part says limit as x approaches 1. The second part is the limit as x approaches 2. And the function is a fraction with a plus 6 next to it. So let's type in the function first of all. So go to the y menu and then click 1 divided by parentheses, then 1 minus x. Close the parentheses and then plus 6 on the outside. There we go, that's the function. Now for the first part of the problem, they want me to find the limit as x approaches 1, and this table that I'm giving you on this page is empty. So when you go to your table, you may have numbers from a previous problem, you could just delete them and not worry about them. Now, I want you to kind of think about what to do here. I want you to plug in numbers that are slightly more than 1, then slightly less than 1, and tell me what the limit is going to be. So maybe pick like 4 numbers before 1, and then 4 numbers after 1. So maybe pause the video here and do that. Keep in mind that the numbers you choose have to be almost 1, but slightly more, slightly less. So like for example, you can pick 0.9. You can pick 0.956. You can pick 0.96887. You can pick 0.989898, for example. And what are you noticing about these numbers in blue? Are they all looking the same? Not exactly. One of them is 16, one of them is 28, one of them is 37, one of them is 104. Your numbers may be different than mine, but your numbers are all going to be also completely random, and depending on how you chose them, they're going to be similar. They're going to be starting very small, and as you get closer and closer to 1, you notice the 9899 is closer to 1 than 0.9. The number is huge. So think about this for a moment. What happens if I plug in like a 9 with a bunch of 9s? All of a sudden, now I have 1 with 6 zeros next to it. That's what this means. So it's a massive, massive amount. Now, if I pick numbers on the other side of 1, slightly more than 1, so like 1.03, or 1.056, or 1.0, I don't know, 2365. You'll notice that again, the numbers are sort of behaving the same way. They're not identical. They're not all close to 27 or 11 or 36 for that matter. And if you put something like 1.00001, for example, you'll notice that the number now is massive. It's 1 with 7 zeros next to it and a negative sign. So it's like really, really, really tiny, really small, okay? So transfer this data to your paper, depending on the numbers you picked. I picked these numbers. And let's take a look at what this means. Well, these numbers in blue are telling me this. They're basically saying that if you pick a number that's approaching 1, but slightly smaller on this function f of x, you will notice that the numbers are becoming bigger and bigger. So plus infinity. As a matter of fact, you remember that one with the 1 and 6 zeros. What about the numbers in red? What are these things saying? These numbers are telling me that if I pick a number that's roughly close to 1, but slightly more, like the 1.01, 1.08, and so on and so forth. If I pick one of those guys and plug it into the function f of x, the answer that I'm gonna get, in general, looks like a negative infinity answer. The closer you are to 1, the lower the curve is going to be. Now this is a problem because the left limit and the right limit are not matching. So what does that mean for the 1? What number should go in the middle? As I approach 1, regardless of direction, on this function f of x, what's the limit? Well, the limit does not exist because the numbers on the left and the numbers on the right are not agreeing with each other. They're not all turning out to be the same amount. Now, will the same thing happen when my x approaches 2, which is the second part of the problem? So again, try to build a table just like the one we made, but with numbers really close to 2. So maybe pick things like 1.8, 1.9, and so on and so forth, slightly before, slightly after 2, and see if you get a pattern on your blue and red outcomes. Are they going to be the same? Are they going to be different? What do you think? I personally chose those numbers, 1.8, 1.9, and so on, and my answers that I'm getting in blue are 4.75, 4.88, 4.98, 4.99. Notice how much different they are from the previous blue numbers. All these guys right here, for all intents and purposes, that's like a 5, right? They're all very, very close to 5. So I can say the following. I could say that the limit as I approach 2 from the left side of 2 on this function f of x, the answer is going to be a 5. Because every time I plug in 1.8, 1.9, 1. Whatever, randomly, I'm getting a number that's close to 5. And your numbers might be different than mine, but your answer is going to be a 5 also, because the ones in blue that you're getting are all going to be exactly like a 5. Same thing as well on the other side. If you pick any number that's slightly more than 2, and how do we say that? We write 2 plus and plug it in to the function f of x. Your answer turns out to be also something close to 5. All these red numbers are very, very close to 5. So what does that mean about the guy in the middle? That means that the limit as x approaches 2 on this function f of x is equal to also 5. That's because the left limit and the right limit are agreeing with each other. They're both turning out to be 5, so that means in the middle there should be a 5 as well. So I want you to kind of compare the two tables with one another. The differences between the tables is these numbers over here and these numbers over here were always close to 5. Nobody can dispute that. You can disagree and you could say like this one's 4.99 and whatever, but they're all, roughly speaking, at the end equal to 5. However, the table on top has random numbers on the left and random numbers on the right that have no pattern. The pattern is that they're all getting bigger or all getting smaller. That's the only pattern there. They're not pointing to the same exact number like 5 or 10 or 100. So that's the reason why we said infinity and negative infinity on that problem. I hope that this makes sense.